Okay guys, let's say we want to solve the equation 2 times the cotangent of x plus 1 is equal to negative 1 on this interval. So what we're going to do is just algebraically, I'm going to work through this and I'm going to show you how to do it graphically as well. Okay, so what I want to do is I want to solve, oops, grab the other end of the pen here. What I want to do is I want to solve for this guy right here. So we'll get this guy by itself. So what I've got, okay, for solving it algebraically, is we've got 2 times the cotangent of x plus 1 equals negative 1. That's our original. We'll move the 1 over, so this gives me 2 cotangent of x is equal to negative 2, and now we'll divide both sides by 2, and so that gives me just the cotangent of x is equal to 1. Excuse me, negative 1. Okay. So now what I'm going to do is this right here, if we're solving for x, okay, which is what we're trying to find. We're trying to find x, right? What we're asking is, what angles give a cotangent value of negative 1 on the interval 0 to 2 pi. So the way of looking at that is what angles on this interval right here, what angles here give a cotangent value out of negative 1. Now, if you finish solving this, you get, like if we apply the arc cotangent to both sides, we get the following. We get the arc cotangent of the cotangent of x is equal to the arc cotangent of negative 1. By definition, since these two guys are inverses, this kicks out just x, and this over here gives me this. Again, it's the same question. What angle has a cotangent value of negative 1? Okay. Now we can do this a couple of different ways. We could use a calculator. Okay. In fact, I'm going to go ahead and I'm going to pull up actually, let's go ahead and use Wolfram. So, arc cotangent of negative 1. Now, depending on the way that the book's defined, or, well, I shouldn't say the book, but depending on the way that Wolfram is defined, this guy should give me a value out that's between 0 and pi. Now, what you're going to notice here is this didn't give me a value out between 0 and pi. So this isn't defined like your book is. Okay, so what do I mean by that? What am I talking about? Well, when you do arc cotangent of some number, the number that's going to be spit out, your book is defining it as a number that's between 0 and pi. Okay. So for you, you'd have to find an angle between here and here that would answer this question. Okay. But this isn't always defined this way. And the reason for that is if I go to the cotangent graph, okay, here's cotangent. Now, if I go from 0 to pi, what you'll notice is that on that interval, this graph between this line and this line, let me make them both the same color. The graph between this line and this line passes the horizontal line test, so I can define it this way. However, I could define it between negative pi over 2 and pi over 2. Notice that on that interval, let me go ahead and make this a little darker here. On this interval, this guy also passes the horizontal line test. So it really depends on which interval you want to pick. So it's defined differently with different books or different software. Okay, but it won't matter for the problem. Watch. So when I plug it in, when I plug this in, okay, I got when I plugged into Wolfram Alpha, I got negative. So I was dealing with the interval negative pi over 2 to pi over 2, and I got an answer out of negative pi over 4. Now, if you think about that graphically, what that's saying is that negative pi over 4 the cotangent value is negative 1. Well, so what? Well, what this tells me is that any angle that's coterminal with this guy will also have a cotangent value of negative 1. So if I add 2 pi, I'll get an angle that is coterminal with this angle and that has a cotangent value of negative 1, which is what I'm looking for. So this would be negative pi over 4 plus 8 pi over 4, or 7 pi over 4. So negative pi over 4 and 7 pi over 4, those two angles are coterminal, so what they'll tell me, or what they'll give me, is if I take the cotangent at 7 pi over 4, or negative pi over 4, and I plug it into this, I'll get negative 1. Watch. So we've got 2 times the cotangent of, let's say, negative pi over 4, plus 1, it gives me out negative 1. Now notice, this negative pi over 4, negative pi over 4 is a solution. Well, what about 7 pi over 4? Well, yeah, sure enough, if I plug in 7 pi over 4, I also get out negative 1. There's an infinite amount of guys that I can plug in here. Now the question is, which ones fall on this interval? Well, negative pi over 4 clearly doesn't. It falls over here. However, 7 pi over 4 does. Okay. Now, is there another angle? Now, if I keep going, if I add another 2 pi, if I take 7 pi over 4 and I go around one more revolution, it'll be too much, right? Because I've gone too far past this interval. Although it would be a solution, watch, that would be 7 pi over 4 plus 8 pi over 4, which is 15 pi over 4. If I go back and I plug in 15 pi over 4, I'll also get a value of negative 1 out. Okay, so it works. If I plug it in here, 15 pi over 4 comes up to be negative 1. But it's too far over on this side. It's not contained within our interval. There is another point, or excuse me, we have to be careful because cotangent is not only negative here, it's also negative over here. Okay, and this value right here is negative 1. So the cotangent at, let's see here, 3 pi over 4, at 3 pi over 4 also equals negative 1. We can check that out again. So cotangent at 3 pi over 4. Yeah, look at that. It gives me negative 1 as well. Okay. Okay. So what? Well, this guy right here, this angle, and anything that's coterminal with it as well are possible solutions. So remember, we're just trying to find all the solutions that work on this interval. Well, it turns out that 3 pi over 4 works plus any revolution, forward or backward. So 3 pi over 4 plus 2 pi, which is 11 pi over 4, is also a solution. So watch, if I go back here and I plug in 11 pi over 4, it works. If I plug in 3 pi over 4, it works. They're all negative 1. So they're all possible solutions. Now, what we need to do is we need to figure out of all these guys, By the way, there's a lot more this way and then back in the other direction. We want to figure out which ones give us a solution that falls in this interval. Well, the only one is 3 pi over 4, because 11 pi over 4 is 2 far. So here is 3 pi over 4. Okay. Now, cotangent, we have to be careful with our range, with our domain. This is really 2, and cotangent is defined as cosine over sine. Now I used theta and I used x, not that big of a deal here. We just have to make sure that these two answers don't make this guy 0 on the bottom. But they don't, because the sine of both these is not 0. So here's our two solutions. Now we can do the same thing graphically. We can take a look. We had 2 times the cotangent plus 1. And we wanted to know when that was equal to a height of -1. And our interval was from 0 to 2 pi. And so what we have are the solutions of 3 pi over 4 and 7 pi over 4. 3 pi over 4 and 7 pi over 4. So don't forget to graph to check to see if these solutions are valid.